Question 23. The sector below is the net for the curved surface of the cone. All lengths are in centimetres. Calculate h, the height of the cone. Give your answer in exact form. So, let's begin by labelling the parts of these two little diagrams that we already know. So we know that this distance here is 4 from this net on the left hand side. So that must also be 4. Bits we need to work out are this vertical height up the middle, and we're also going to need to know this distance around here and the radius. So there are lots of different things we need to work out here, and we need to start by using this net on the left hand side to find this distance around here. So to find the circumference of a circle, we would do pi times the diameter. So the diameter here would be 8 because we've currently only got the radius, so it would be pi times 8, which we're just going to leave as 8 pi for now. Now, because this is a right angle, we've got a quarter of a circle here, so this arc length is going to be a quarter of 8 pi. So if I then divide that by 4, that tells me what the distance is around here. Now, I can then also label that on my picture over here. We know that the distance all the way around the circumference is 2 pi. So now we need to use that to work out the radius. So if we write out the formula again for the circumference of a circle, the circumference equals pi times diameter. Well, we already know what the circumference is this time. We know it's 2 pi. So 2 pi equals pi times the diameter. Well, pi times something is 2 pi, so diameter must be 2. So if the diameter is 2, the radius is going to be half of that, so the radius must be 1. So that distance there must be 1. And we're almost there now. So now we should be able to use that to help us work out this vertical height up here. We've got a right angled triangle here, so we can use Pythagoras' theorem because we know 2 of the lengths. And we're looking for one of the shorter sides, so we're going to be subtracting. So we'll write out a theorem, h squared, it's going to be 4 squared, which is the hypotenuse, take away 1 squared, which is one of the shorter sides. So h squared is, 4 squared is 16, 1 squared is 1, so 16 take away 1, so h squared is 15. If h squared is 15, then h is going to be the square root of 15. Notice it says leave your answer in exact form. There's nothing we can do to make it more exact than the square root of 15. So that's our answer. Part B, a mathematically similar sector has a radius of 8 centimetres. Find the height of the cone that can be made from this sector. So the radius originally was 4, so if it's got a radius of 8, it's been doubled. So the scale factor is 2, so it's twice the size. And because they're lengths, that means that the height would just be twice the size. So 2 lots of root 15 would just be written as 2 root 15.